Okay, so up next here we have lesson 7-6 for Math 7 on circle vocabulary. Very, very important lesson because it does have a lot of vocab that you might not be familiar with, and the rest of these problems afterwards can be a little bit confusing if you're not familiar with the vocab. So, first off, we usually start talking about a circle, and you guys usually come up with things that circles have no sides, no corners, no edges. You usually come up with the fact that it's 2D, two-dimensional, and then you tell me that the 3D version is a sphere, which is 100% correct. You usually tell me that it's round, right? The fact that it has no corners, it's not straight, it's round. And then we usually come up with the fact that it's 360 degrees. So that's what you guys know circles to be. The official definition, which I'm going to abbreviate with DEF, the official definition of a circle is the infinite number of points that are an equal distance. Sometimes you'll hear that called an equidistant. So the infinite number of points that are an equal distance from the center of your circle. And that makes sense because if you think about the circle and you make your center, and if you haven't drawn, if you have not drawn a circle on your paper, please do so. And then just go ahead and fill in around your circle a whole bunch of little dots. Make sure they're on your circle. I mean, obviously, it doesn't have to be perfect because mine's not. But, this is what the circle is composed of. This circle has an infinite number of tiny little points or tiny dots on it that make up the circle. And, the more I zoom in, the more of these dots that I could, continue filling in along the circle's edge. We obviously could not fill in all of them because we could never, zoom in enough to put an infinite number of points. Not to mention the fact that we could never plot an infinite number of points. That's the whole point of infinity. So, boom, that's a circle. Those points, every single one of those infinite number of points is the same distance. So looking at that distance, looking at one of those points along the edge all the way into the center. I wish that was straight. I could probably get a straight line and draw it in and actually utilize the technology I have, maybe. How about that? Good enough. So that distance from that distance, and then again, if we do that again, from the center out, which not perfectly straight, but boom, those are the same distance. I can draw an infinite number of those, all being the same distance from that center of the circle. And that distance that we're talking about is what's called the radius. So the radius is the distance from the center of the circle to any point on the circle. So again, from the center to any point on that circle. Each one of those three things that we created is a radius. And the plural of radius, okay, just decide to stop working. Come on. There we go. The plural of radius is either one. You can call it radii or radiuses. Doesn't matter. Right. All three of those are a radius, and all three of those are the same exact length. Okay, so that leads us next to a diameter. And a diameter is more or less the width of the circle. It is extremely important because when we're measuring the width, if I were to draw something from here to here, does that accurately measure the width of the circle? You know, how wide the circle is. And it would be no, because it's not going through the center. So it's absolutely essential that when you're talking about the diameter, that it goes from one endpoint to another, but it must go through the center. So I can draw a radius, or sorry, a diameter going from one endpoint all the way to the other side, making sure that it hits that center, and that would be my diameter. So you might be noticing that we need to kind of take a little bit of a look at the relationship between a radius and a diameter. To draw my diameter, I went from one endpoint to the middle, and then from the middle to the other endpoint. Well, we already decided that from one endpoint to the middle, that was called a radius, right? Each one of these is a radius. And essentially, this one also is a radius, right? All 1, 2, 3, 4, 5 of those are the same length. So therefore, that means if this highlighted length is the radius, and this highlighted length is also the radius, and together those make the diameter is actually equal to twice or two times the radius, right? Radius plus radius. That's not actual radius. Sorry, radius. Radius plus radius equals diameter. And playing along with that, if I have the diameter and I want to go backwards to get the radius, if I have the equation d equals 2r and I want to solve for r, 2 and r are being multiplied, so I would divide, leaving r equal to your diameter divided by 2, or 1/2 of your diameter. Or, as we've been practicing substituting, 0.5 times your diameter. So that means if I, go off to the side real quick, if I have a radius of 5, my diameter would then be 10. If I have a diameter now of 20, that means my radius would be half of that is 10. If I have a radius of 7, my diameter would be 14. So that relationship between the radius and the diameter is super important to understand. It's super important that you make sure you understand the difference between them.